Okay, so for problem number two, a local boutique produced two designs of gowns, design A and design B, and has the following materials available: 18 square meters of cotton, 20 square meters of silk, and 5 square meters of wool. Design A requires the following: 3 square meters of cotton, 2 square meters of silk, and 1 square meter of wool. While design B requires the following: 2 square meters of cotton, 4 square meters of silk. If design A sells for 1,200 pesos and design B for 1,600 pesos, how many of each designs should the boutique produce to obtain a maximum amount of money? Okay, here in our problem, we have a local boutique that produced two gowns, which is design A and design B. Okay, and then it provides the materials needed to produce those gowns. And also it indicates the selling price, but it does not indicate the profit. Okay, but the question here is we are after with the maximum amount of money to earn. Okay, so let's solve this. So again, for the first step, we need to recognize the independent variables here. Okay, in this case, we need to identify the number of gowns for each design. Okay, to produce a maximum amount of money. So let's say we represent X as the number of design A. Should be the boutique must produce, and then Y be the number of design B that should be the boutique must produce. Okay, again, when it comes to its variables, we are after with its quantity. Okay, for each design. Now for the step two, since the materials are presented, we need to consider the cotton, the silk, and the wool. Okay, and then for the step 3, let's include the price. Okay, for the total selling price. Okay, so for design A and design B, uh, based on the problem, for design A, it requires 3 square meters for each design A. Okay, and then for design B, we have 2 square meters of cotton for each design B gown. Okay, all, in total, the materials available, the cotton available is 18 square meters. Okay, that is 18 square meters. And then for the silk, we have 2 square meters for design A, and then for design B, we have 4 square meters. And then for the available material for the silk, we have 20 square meters. And then for the wool, for design A, we have 1 square meter. And then for design B, we don't need a wool. Okay, and the total available materials is 5 square meters. And then for the selling price, for design A, we have 1,200 pesos. While for design B, we have that 1,600 pesos. And take note again, we don't know the total price. Okay, the total amount of money. Okay, the maximum amount of money. So let's represent that as Z. Okay, so again, for the step number 2, we have here the cotton, the silk, and the wool. And then for the step 3, we have the total maximum amount of money. Okay. So let's start first with the cotton. So as you notice, same procedure from our first problem. Since the maximum number of available material for the cotton is 18 square meters, we can say that we have here for the cotton 3x plus 2y less than or equal to 18. Okay, so again, 3 times the quantity of design A gown, and then plus 2 times the quantity of the design B gown. Less than or equal to 18. So again, it is less than or equal because the maximum, okay, or the available material here is only 18. Okay, and then for the silk, same procedure. We have 2x plus 4y less than or equal to 40. Okay, so we have 2x plus 4y less than or equal to 20. And then for the wool, we have 1 times x, that's x. And then 0 times y, that's 0, less than or equal to 5. Okay, so x plus 0 less than or equal to 5. Or just simply x is less than or equal to 5. And then take note that we need to consider that the values of x and y here are always positive. Okay, or it could be 0. So we can restrict that by x greater than or equal to 0 and y is greater than or equal to 0. Okay, and then for step number 3, again, we need to represent that using a linear equation. So our objective function is 1200x plus 1600y equals z. And then for the step number 4, we need to graph the feasible region. So for us to graph the feasible region, again, one way is to use the Desmos, or the other one is you can use the manual way of graphing the inequalities. So first off, we have 3x plus 2y less than or equal to 18. So finding the intercepts, again, for the x-intercept, we let y be equal to 0. So we'll have 3x plus 2 times 0, that is equal to 18. Okay, and then 2 times 0 is 0, so 3x is equal to 18. And then dividing both sides by 3, that is x is equal to 6. So therefore, the x-intercept here is 6 comma 0. And then for the y-intercept, we let x be equal to 0. So we have here 3 times 0 plus 2y is equal to 18. 3 times 0 is 0, so 2y is equal to 18. Dividing both sides by 2, we'll obtain y is equal to 9. So our y-intercept here is 0 comma 9. Okay, and then take note again, all you need to do is to plot it in our Cartesian plane, then we connect them and extend both sides. Okay, and at the same time, we're going to have the solid line because we have less than or equal. Okay, less than or equal as our inequality symbol here. And since it is less than, the shaded region here is in the lower part. In our lower part. So here's what will be. Here's the graph. Okay, the y-intercept 0, comma 9 and the x-intercept 6, comma 0. Okay, and then we have the solid line because we have the less than or equal. Okay, and then less than or equal, so therefore we have the shaded region below. Okay, another one. We have 2x plus 4y less than or equal to 20. So same procedure, we need to identify the intercepts here. So for the x-intercept, we let y be equal to 0. So we'll have 2x plus 4 times 0 is equal to 20. And 4 times 0 is 0. So 2x is equal to 20. And dividing both sides by 2, x is equal to 10. So therefore, we have 10 comma 0 as our x-intercept. And then for the y-intercept, we let x be equal to 0. So 2 times 0 plus 4y is equal to 20. And then 2 times 0 is 0. So 4y is equal to 20. Divide both sides by 4. Y is equal to 5. So therefore, the y-intercept here is 0 comma 5. Okay, so same again, inequality less than or equal. So therefore, we have a solid line and our shaded region here is below. Okay, so we have here the y-intercept 0 comma 5, x-intercept time comma 0. We have the shaded region below. The next one, we have that x is less than or equal to 5 and x is greater than or equal to 0 and y is greater than or equal to 0. Okay, so for x is less than or equal to 5, so all we need to do is to shade all area that includes the values of x that is less than or equal to 5. And then for x is greater than or equal to 0, so that is still quadrant number 1 and quadrant number 4. And then y is greater than or equal to 0, that's quadrant 1 and quadrant number 3. Okay, so same from problem number 1. And here again, we have x is less than or equal to 5. So just identify 5 here in our x-axis. And then shade all the regions. Okay, all the part here that is less than 5. which is 4, 3, 2, 1, 0, and so on. So this is the shaded region. Okay, so now let's combine. Okay, let's combine all the five inequalities. So here's what will happen. So again, the black part here is the 3x plus 2y less than or equal to 18. The green part is 2x plus 4y less than or equal to 20. And then the violet one is x is less than or equal to 5. And then for the blue, we have x is greater than or equal to 0. And then the red one is y is greater than or equal to 0. So again, same procedure. We need to identify the feasible region wherein all the shaded regions intersects. Okay, it intersect with that area. Okay, in this case, we have this. Okay, we have this area. Okay, and then the rest, it intersects two or more, but not all. Okay, not all the inequalities. So same procedure, we need to identify all the corner points here. So here, first we have the origin, okay, which is 0, comma 0. And then we have here the y-intercept for 2x plus 4y less than or equal to 20, which is 0, comma 5. And then here we have an x-intercept, okay, for the graph x is less than or equal to 5. In this case, this is 5 and then it's on the x-axis, so 5, comma 0. Okay? So now, how about this 2? Okay, these 2 points. So let's start first with this one, this point. Okay, so as you notice, there are two graphs that intersects. The first one here is the uh, inequality 3x plus 2y less than or equal to 18. Okay? And then the other one is x is less than or equal to 5. Okay? So let's identify the point of intersection. So again, we need to use the equation, okay, of this 3x plus 2y equals 18 and x is equal to 5. So the first equation here is 3x plus 2y is equal to 18. And then for the equation 2, x is equal to 5. Okay, so again, this point, it intersects the two inequalities 3x plus 2y less than or equal to 18 and x is less than or equal to 5. Okay, so we have here equation 1 and equation 2. So let's substitute the value of x here of equation 2 to equation 1. Okay, so 3 times 5 plus 2 y is equal to 18. And 3 times 5, that's 15. Okay, and then addition property of equality or just transpose, that's minus 15. So 2y is equal to 18 minus 15. And 18 minus 15 is 3. Okay, so dividing both sides by 2 will have 1.5 or 3 halves. Okay, so the ordered pair here for this is 5 comma 1.5. Okay, 5 comma 1.5. And then this next one, we have the intersection of, again, 3x plus 2y less than or equal to 18 and 2x plus 4y less than or equal to 20. Okay, so with that, again, let's transform it into equation. So for computing the other corner point, let's say the first equation is 3x plus 2y is equal to 18. And the second equation here is 2x plus 4 is equal to 20. Okay, for this one. Okay, so same procedure from the previous problem, from problem number 1. We need to think of a way that we can eliminate one variable here. Okay, so here, one strategy, you can divide equation 2 by 2, or you can multiply equation 1 by 2. Okay, so either of the two. Again, you can divide equation 2 by 2, or you can multiply equation 1 by 2. Okay, so multiplying equation 1 by 2, so we'll have 3x times 2, that's 6x. 2y times 2, that is 4y. And then 18 times 2, that's 36. Okay, that is equation 1.1. And then since we have here the same as 4y, let's subtract. Okay, let's subtract equation 1.1 to equation 2. Okay, so we'll have 6x plus 4y equals 36, and then minus 2x plus 4y is equal to 20. And 6x minus 2x, that is 4x. And then 4y minus 4y, that is 0. Okay, so let's just cancel this one. Okay, that is 0. So 4x, and then 36 minus 20, that's 16. So 4x equals 16. So dividing both sides by 4, x is equal to 4. Okay, so x is equal to 4. Now, for us to identify the value of y, okay, for us to identify the value of y, let's substitute that x to equation number 1. It should be y. Okay, so to find the value of y, we need to substitute x. We need to substitute x. So 3 times 4 plus 2y is equal to 18. And 3 times 4, that's 12. 3 times 4, that's 12. And then addition property of equality, or just transpose. So 18 minus 12. 18 minus 12 is 6. So 2y is equal to 6, dividing both sides by 2. Y is equal to 3. Y is equal to 3. So if x is 4 and y is equal to 3, we have now the corner point here as 4 comma 3. Okay, we have 4 comma 3. Okay, so therefore we have 5 corner points here. So if we're going to graph again using Desmos, you can easily identify the corner points. Just look at the feasible region. Okay, just identify the feasible region, and the Desmos will provide the corner points to you. Okay, so now for step 5, we have now the corner points. Let's substitute that to our objective function. Okay, and our objective function is 1200x plus 1600y is equal to z. Okay, so again, let's substitute each ordered pair. So let's start first with 0, comma 0. So if x is 0 and y is equal to 0, so 1, 2 times 0 plus 1, 6 times 0, the total amount of money is 0. And then if x is 5 and y is 0, so we'll have 1200 times 5 plus 160 times 0 equals z. And 160 times 0 is 0, and 1200 times 5 is 6000. So total amount of money, if x is 5 and y is equal to 0, is 6000. And then if 0, 5, okay, if x is 0 and y is 5, 1200 times 0 plus 1600 times 5, and z is equal to 8000. Okay, so the total amount of money is 8000. And then if we have 4, comma 3, if x is 4 and y is 3, 1200 times 4 plus 1600 times 3, that is 9600. That is 9600. And then lastly, if 5, x is 5 and y is 1.5, we'll have 1200 times 5 plus 1600 times 1.5, and the sum of that is 8400. So comparing them all the total amount of money, we have here the highest, which is 9600, and that is 4 comma 3. So the value of x here is 4, and then the value of y here is 3. Okay, so x represents the number of gowns for design A, and then y represents the number of gowns for design B. So therefore, we'll have our conclusion as the maximum amount of money that a boutique can obtain is 9600 by making 4 design A and 3 design B of gowns. Okay, so again, this is the value of x, and then this is the value of y. Okay, that identifies the quantity. And then this is our z. Okay, so that is problem number 2. So let's proceed with problem number 3. Okay, so when it comes to problem number 3, we have this. A vegetable farmer in Rizal ships at most 900 baskets of vegetables on a freight truck daily to a certain Quezon City public market. He must ship at least 550 baskets of lettuce and at most 200 baskets of celery. Furthermore, his profits are 200 pesos per basket of lettuce and 225 pesos per basket of celery. How many number of baskets of lettuce and celery he should be loading the freight truck in order to maximize his profit? Okay, so here, again, we need to identify the independent variables to identify the maximum profit. We need to have the quantity for the baskets of lettuce and the basket of the celery. Okay, so for step number one, again, let X be the number of baskets of lettuce should the vegetable farmer must load in the freight truck. And let Y be the number of baskets of celery should the vegetable farmer must load in the freight truck. And then for step number two, again, we need to have the constraints. Okay, we need to identify the constraints. So based on the given situation, we have the limitations for the number of baskets for the lettuce and the celery. So from the problem, it indicates that the number of baskets of vegetables for the lettuce, it should have at least 550. It should have at least 550. And then for the number of baskets of the celery, it should have at most 200. Okay, at most 200. And then the total number of baskets, okay, the limitation is at most 900. Okay, it is at most 900. Okay, and then for the profit per basket of lettuce, we have 200 pesos. And then for per basket of celery, we have 225 pesos. And then again, we don't know the maximum or the total maximum profit. So let's represent that as Z. So let's start first with the constraints. Let's start first with the constraints. So we have here the word at least. So take note, if we have the word at least, we represent that by greater than or equal. If we have the word at least. And then if we have the word at most, we represent that by less than or equal. Okay, so in this case, we have x as our, the representation of the number of baskets. So we can say that we have x is greater than or equal to 550. And then the number of baskets of celery, at most 200. So that is, y is less than or equal to 200. Okay, and then the total number of baskets. Okay, so the sum of the number of baskets of lettuce and the celery is at most 900. So again, at most, we represent that by less than or equal to. Okay, and that is x plus y. Okay, the sum of the two is less than or equal to 900. So now, with this, let's have the other limitations, the other constraints to consider. So let's start first with the values of x. Okay, so given that the values of x is greater than or equal to 550, obviously we don't need that x is greater than or equal to 0, right? We don't need that x is greater than or equal to 0 because we are sure that x is greater than or equal to 550. It's greater than or equal to 550. Okay? So let's have its limitation, okay? Its maximum amount that we can have for the value of x. So since we have here the total number of baskets as at most 900, we can say that the maximum number of x, okay, is uh 900. Okay? And also when it comes to the limitations of y, it's still y is greater than or equal to 0. Okay, for us to indicate that there should be no negative values. Okay, so provided that y is greater than or equal to 0, so the minimum number of y is 0. So if we replace that by 0, okay, if we replace it by 0, okay, so we'll obtain as x is less than or equal to 900. Okay, as x is less than or equal to 900. So take note, again, since we know that x is greater than or equal to 550, we don't need that x is greater than or equal to 0. So let's have its maximum value, okay, which is x is less than or equal to 900. So if we substitute that y as 0 here, so we have that x plus 0 less than or equal to 900, or x is less than or equal to 900. Okay, so we have this as our constraint. Okay? So we have now the constraint for the x and then for the y. And then also, let's have the constraint for the sum. Okay, let's have the constraint for the sum. So, since we don't need, we can't have a negative value for its sum, let's say we have the sum should be greater than or equal to 0. Okay, the sum should be greater than or equal to 0. So, in this case, we have 6 constraints. Okay, we have 6 constraints here. Okay, and then for the next one, for step number 3, for the profit, so let's represent that as linear equation. So we'll have 200x plus 225y is equal to z. Okay, from the third column of our previous slide. 200x plus 225y is equal to z. Then for the step 4, we need to graph the feasible region. So we have here x is greater than or equal to 550, and then x is less than or equal to 900. So notice again that x should be greater than or equal to 550. So all we need to do is to identify that 550 here, okay, in our x-axis. Okay, so this is 550. And since we know that it should be greater than 550, so we'll shade the right portion, okay, the right side of this Cartesian plane. So we'll have that x is greater than or equal to 550. Then here we have x is less than or equal to 900. So since it's less than, we shade the left portion. Okay, so let's say this is 900 in our x-axis. Okay, and then we are after with it's less than values. Okay, less than or equal to 900. So we have this as our graph. Okay, and then next one, we have that y is less than or equal to 200. Oh, since this is y values, so let's shade all the values that is less than or equal to 200. And the next one, we have x plus y less than or equal to 900. Okay, so here, again, we have y is less than or equal to 200. Okay, so let's shade the portion that is lower than that 200. Okay, in our y-axis. Okay, so less than 200, so we shade it below. And then we have here x plus y is less than or equal to 900. So, if you will recall, we need to identify its intercepts. We need to identify its intercepts. So, this time we have the intercepts if we let x be equal to 0. So, y is equal to 900. If we let y be equal to 0, x is equal to 900. So, we have the intercepts 900, 0 and 0, 900. Okay, and then since this is less than or equal, again, it's a solid line. And at the same time, we will shade the lower portion. We will shade this lower portion of this. The next one, we have x plus y greater than or equal to 0. And then y is greater than or equal to 0. So x plus y greater than or equal to 0. So identifying its intercepts. If we let x be equal to 0, so y is equal to 0. If we let y be equal to 0, then x is equal to 0. So the intercept here is at the origin. Okay, and then notice that this is greater than or equal to. Okay, since this is greater than or equal to, this is a solid line. And then since it's greater than, we shade the upper part. Okay, we shade the upper part here. Okay, and then we have y is greater than or equal to 0. So obviously, all the values in quadrant 1 and quadrant 3. Okay, so shade the quadrant 1 and quadrant 3. Okay, for y is greater than or equal to 0. So now, let's combine. Okay, so if we're going to combine that, we'll have this graph. We'll have this graph. So again, the blue part here is the x is greater than or equal to 550. And then we have the orange part, which is x is less than or equal to 900. And then the violet part is y is less than or equal to 200. And then the black part is x plus y is less than or equal to 900. The green part is x plus y is greater than or equal to 0. And then the red part is y is greater than or equal to 0. So it overlaps, right? It overlaps. But this time, again, we need to recognize the feasible region. So as you notice, x should be greater than or equal to 550. So obviously, we need to identify all the values that is greater than or equal to 550. So we'll start here in this portion. This is 550. Okay, on this right side of 550. And then, obviously, y is greater than or equal to 0. So it's on the first or the first and the third axis. We don't have here for the second and the fourth quadrant. Okay, and then y should be y should be less than or equal to 200. So obviously this one in this portion. Okay, and then again this is one. X should be greater than or equal to 550, and then x should be less than or equal to 900. Okay, so x should be less than or equal to 900. So this is the portion of that. Okay, and then we have here x plus y less than or equal to 900. So this portion, the black one here. So let's graph that. Then again, we need to have a positive values. So that's why we have this. Okay, so the feasible region here is this one. The feasible region here is this one. Okay, so we have here again 550. So that's 550 comma 0. And then this one, this is 900. And then this one is 200. Okay, 200 and 550. So 550 comma 200, and this one 900 comma 0. Okay, 900 comma 0. So we have here again this one 550 and then 200. This one 900 comma 0. And then this last one, we don't know its x value, right? We don't know its x value, but we are familiar with the y value, which is 200. So we can use this, again, the intersection of y is less than or equal to 200, and the x plus y less than or equal to 900, the black portion. Okay, so let's say we have the equation 1 as x plus y equals 900, and then we have y is equal to 200. So let's substitute that y to the equation 1. So we'll have x plus 200 is equal to 900. So by addition property of equality, add both sides by negative 200 or just simply transpose, we'll obtain x is equal to 900 minus 200. 900 minus 200, that's 700. Okay, so therefore, the ordered pair here, the corner point is 700 comma 200. Okay, so we have now the four corner points, 550 comma 0, 900 comma 0, and then 700 comma 0, 700 comma 200, and then lastly 550 comma 200. Okay, and then also in Desmos, again, you can type the six inequalities, and then just recognize, okay, just recognize the feasible region, okay, the intersection of all the shaded regions. Okay, so for the step 5, again, we identify the corner points, and we need to substitute that in our uh, objective function, which is 200x plus 225y is equal to z. So first off, if x is 550 and y is 0, so that is 200 times 550 plus 225 times 0. So that is 110,000. Okay, so the profit here is 110k. And then if x is 900 and y is 0, so we'll have 200 times 900 plus 225 times 0. And the total profit there is 180,000. And then if x is 700 and y is 200, so 200 times 700 plus 225 times 200 equals z. Okay, the sum of that is 185,000 pesos. And then lastly, if we have x as 550, correction, this should be 550, comma 200. So 200 times 550 plus 225 times 200, and that is 155,000. So if we're going to compare them, okay, so if we're going to compare all the values of z here, we have the highest or the maximum profit of 185,000 pesos. So therefore, the value of X here is 700. The value of Y here is 200. Okay, this represents the number of baskets for the lettuce and for celery. So therefore, we can have the conclusion. The vegetable farmer needs to ship 700 baskets of lettuce and then 200 baskets of the celery to have the maximum profit. Okay, the maximum profit of 185,000 pesos.